All right, guys, we're going to go over how to do this foldable here. So grab this foldable. This should be the first one in your packet. And the first thing I want you guys to do is go ahead and cut out around the exterior of it. All right, after you cut out the exterior, it should look like this. Now notice these dotted lines here and here. So all I'm going to do is I'm going to fold these towards me. And then crease, so it looks like that. See how I did that? And then I want to do the same thing over here. Let's fold these almost to where those singular words cover up the other words. So it should look like this. So go ahead and do that real quick. All right, so now you have these two bigger flaps here. So now there's some solid lines here. I just want you to cut along those lines, not both sides, just on the flap side, so that these will end up being flaps and you could fold them up to see what's under them. All right, so when it's all folded correctly, it should look like this, to where you can open these and see what's under them. And now we're going to spend some time filling out what's on the under part of each of those flaps. All right, guys, so now if you fold up this conditional statement flap, okay, you should see what's right here on the right side. Okay, now we'll do some examples of these so that'll make more sense, but conditional statements typically can be written in if, then form. Okay, if then form. So if an animal barks, then it is a dog, something like that. It always has the word if to start and then in the middle. And conditional statements, we know, can be either true or they can be false. They're not always false, they're not always true, they can be either or. So an example of an if-then statement is, if you work hard, then you will like geometry. Now, for some of you, that is a true statement. For others of you, that's a false statement. That's okay, whichever way. But the main thing is, this here is a conditional statement. Okay, every conditional statement has two parts. It has a hypothesis, which, as you know from science, hypothesis always comes before a conclusion. So the first part is the hypothesis and the second part is the conclusion. So if we look at this, the hypothesis would be you work hard. Okay, and the conclusion would be you will like geometry. All right, now notice conditional statements, mathematically speaking, this is the way it's written. Okay, in this P arrow Q, we would say if P, then Q. Okay, so in this case, P is the hypothesis. So P is the hypothesis. And Q is the conclusion. And guys, this will make more sense after we do a couple of examples. All right, now notice that when we flip over the converse tab, so we're looking under the converse tab now, what we see is right here on the right, okay? So it says example, if B is between A and C, then AB plus BC equals AC. Now if we go down here, if you remember, the conditional statement was if P, then Q, where P is the hypothesis and Q is the conclusion. Well, now notice we have Q arrow P, so we would say this is if Q, then P. Okay, so notice how these are flipped. Okay, so now in this converse statement, the Q is now the hypothesis, when before it was the P, and the P is now the conclusion. So all we've done is we switch, or we flip, the hypothesis and the conclusion. Okay, so the hypothesis is B is between A and C, and the conclusion is AB plus BC equals AC. So if we write the converse of this, all we're going to do is flip the order that these two happen. So we would say if, now we're flipping these, so it would be if AB plus BC equals AC, comma, then, now the conclusion would be the hypothesis before, which would be, then B is between A and C. All right, let's flip over the contrapositive tab now. So if you flip over the contrapositive tab, you'll get what's here in the middle or on the right of the screen. And the contrapositive notice is this down here, okay? And these little squigglies is a not, okay? So in words, we would say if not Q, then not P. That's how we would say this statement here. So if not Q, then not P. Okay, so notice that all we're doing is we are negating, which negating is saying, negating is doing the opposite of, so when we say not, that would be negating. And we are switching the hypothesis and the conclusion, and I'm going to put of the conditional statement. Okay, so if we take the conditional statement, we negate both parts, and we flip the hypothesis and conclusion, we'd get this. Now, like I said, this will make more sense after we do a couple of examples. So the hypothesis is the not Q, the whole thing, it's a hypothesis, and the not P is the conclusion. So if this is my conditional statement, so if my conditional statement is, if two angles are vertical angles, then they are congruent, my contrapositive would be, all right, so if I want not Q, okay, so not the hypothesis. So if they are, don't forget, not congruent, comma, then and don't forget, we're knotting this, then two angles are not vertical angles. All right, I know I've kind of already done an example of this. I should have done this before I did the contrapositive, but I didn't, and I apologize. So let's go to the negation tab. So if you flip the negation tab down, you should get this right here under it. So the opposite of a statement is, and this is said, not P. Okay, this little squiggly is a not. All right, so if we have an example, if the example is, it is raining, okay, the negation of this, or to negate it, would be, it is not raining. We're just doing the opposite of. So it either is or it isn't raining, one of the two. All right, let's look at the inverse now. Okay, so we're going to flip the inverse tab over, and we'll get this right here. Now when we flip it over, we see that in math terms, it's if not P, then not Q. Okay, that's how we would say this. So our hypothesis in this case is the not P, and our conclusion in this case is the not Q. Okay, so all we're doing is we're taking the conditional statement, because remember the conditional statement is if P then Q, and all we're doing is we're negating both the hypothesis and the conclusion. Okay, so if the example is, if it is sunny, then it is hot. Okay, the inverse of that would be, if it is not sunny, then it is not hot. Okay, now notice we didn't switch the order. All we did is made both the hypothesis and the conclusion not. All right, the last tab we need to go over is the equivalent statements tab. So if you flip that up, equivalent statements are just two statements that are either both true or they're both false. So they have the same truth value. Now, something to remember is that conditional statements and its contrapositive always have the same truth value. So if a conditional statement is true, the contrapositive has to also be true. Or if the conditional statement is false, the contrapositive will be false as well. These will always have the same either true or false. And then the inverse and the converse are the same way. Okay, inverse and converse are the same way.